the video on a survey of quadric surfaces. So, what is a quadric surface? So basically, the definition is a quadric surface is so a quadratic equation. I'll just abbreviate a couple things in 3 variables. So we'll say in 3 variables instead of 2, right? In 3 variables, and then so that's basically it. That's the definition of it. So we'll be looking at examples. We'll be looking at some examples, actually the traces of them, but looking at a few examples of a couple of these quadric surfaces. Examples. So let's start with the ellipsoid. So these kind of have cool names. Ellipsoid. Right? So what is an ellipsoid? It has the form of x over a and then quantity squared plus y over b quantity squared plus z over c quantity squared is equal to a 1. Okay? So this means that in the x direction we'll be going a and either on the x-axis. So what that means, let's look at the graph here. So we have an x, a y, and a z. Okay, so here's our negative x direction, our negative y direction, and our negative z direction. So in the x direction, we'll be going a, positive a, and negative a. So here's a, and here's negative a. In the y direction, we'll be going positive b, so I'll just draw it out there, and a negative b in the other direction. And in the z direction, we'll be going a positive c, and in the negative z direction, a negative c. Okay, so what does this look like? We're actually going to have some kind of like drawing all of the different ellipses being formed, right? So something like that on the YZ plane, going through the C's and the B's. If we go in the XZ direction, we'll be going through the C's and the A's. So this is kind of looking like end up looking like an egg, sort of. And then in the YX direction, we have some kind of we're going through the A's and the B's. Okay. And I'll tell you guys just now, this looked a lot better on my paper. But anyway, so you can kind of picture like an egg, like kind of an ovally thing. Anyway, so this is basically like an ellipsoid is made of ellipses going in, shooting in like the 3 different directions. Okay? So yeah, so that's the ellipsoid. Let's look at an example of like what would a problem involving an ellipsoid look like. So we're going to describe the traces of, and I'll give you a specific ellipsoid, so x over 5 squared plus y over, we'll say 7 squared, plus a z over 9 squared equals 1. So this is the equation for an ellipsoid, right? The one we just learned, ellipsoid. Okay, so what we're going to do for a trace is freeze certain variables, right? So let's, first of all, we'll say that we're going to freeze the z variable. So we'll freeze that at 0. So it's usually convenient to freeze things at 0 because then it basically just goes away and you don't have to deal with that variable. So anyways, so if we freeze z at 0, we would get x over 5 squared plus y over 7 squared plus 0, right? 0 squared is equal to 1. So what does that look like? Let's start graphing that. So if we have our x, y, and z axes, this means that we get an ellipse that goes 5 in either direction on the x and 7 in either direction on the y. So let's say here's 5, and there's, I'll just draw the negative axis, there's negative 5. So here's 5, there's negative 5, and here's 7, and here's our negative 7. Okay? Alright, so we would have an ellipse that looks kind of like that, sort of, right? So something a little bit more oblong in the y direction. Okay, so here's our first ellipse. That's our horizontal trace, right? Because we set z equal to 0. Now let's freeze another variable. So instead, let's freeze the y variable at 0. Okay, so z is equal to 0, so we're looking at the xz plane. Okay, so this is going to be x over 5 squared plus z over 9 squared is equal to 1 because the whole y term went away. So this is going to be, it goes in the x direction, 5 in each direction, and then on the z axis, we go up 9 and down 9. So that's going to be kind of longer, right? So something like that. So here's 9 up there, and there's -9. So if we draw that, and here we're drawing it on the XZ plane, so we want to go through the 5s and the 9s, right? So something like, it's kind of facing away from us, right? So it's being a little bit like skewed, okay? And lastly, let's freeze the X at 0. So then our X term goes away, and we're left with Y over 7 squared plus Z over 9 squared is equal to 1. So here we see we're going to go through the 7s and the 9s, basically, okay? So we have something looking, this one's facing us directly, like head on, right? So something like that, and this kind of looks a little bit egg-shaped. But yeah, so that's basically it. So that's what we have, and as you can tell, so these are the traces, right? So this would be a trace, and this would be a trace, and this would be a trace, and each of those would correspond to the ellipses that I drew, right? So the first one would be 5 and 7, so that would be the flat one, like the one laying down on the floor, kind of, on the XY plane. So this one here, okay, this one here, when we have Y equals 0, then that means that we have the one facing away from us, right? So the one that I'm kind of tracing over now, the very narrow one, and then our X equals 0 one is the one directly facing us and completing that egg shape on the outside, okay? But anyway, so those are the traces, and just another thing to note is that by constructing traces, we can see from this example, we got a pretty good idea of what our surface looks like, right? It's kind of like this eggy shape, okay? Alright, so now on to the next topic.